How's it going, everyone? Welcome. Euler Gonzalez here again, and today let's going to talk about is the hard part of Node.js, but specifically to understand now how Node execute code, the inner mechanism of this. So this course is to understand now the how servers work, at least to make a quick recap of how servers work, the nature of HTTP and this communication using the TCP protocol, transfer control protocol, where instead of focusing on controlling the network, which it is something that its predecessor did, the network control protocol, now those people back then, they realized that, hey, it is quite complex, because especially if you have now a small network, you can control that, but as you have to aggregate more networks and guarantee the communication across all of these different networks, things becomes a problem. It's a problematic stuff. So how they solve this, instead of focusing on the controlling the network, they're focused on define some set of rule between the communication, and that's something beautiful to at least understand that. Why is that? Because now that gives you a lot of sense of when we are now building servers, or understand now here is the hard part of Node, which is specifically on the server hard part of server and Node, the hard part of servers and Node.js, please, Node.js, all right, is that because this is now the fundamental in which now we care about is, or we need to understand now how this communication is going to happen over TCP, over this protocol, this transfer protocol, the transfer control protocol, or I mean transmission, sorry, is it transfer, transmission, you get the idea. Is the same as is that instead of focusing on controlling the network, all right, as an admin network, so let's go now to look at things from different perspective, because what we really care about is that the communications that happen end to end with less error prone, so in a reliable way. So I don't care here is the network in which this component are, or in this device are, the server or the client, nor the architecture in which this client or server is running. In other words, I don't care if that is an ISA architecture, let me actually take a look at the architecture here. Okay, this is architecture, computer computer architecture, computer architecture here, like this. All right, but I just want to bring that out, that come on, man. Okay. At a more detailed level, the description may include instruction set architecture, design microarchitecture, also called the computer organization, logic design, and implementation. But if we take a look at this instruction set architecture, complex instruction, there you got it. Complex instruction, yeah, complex instructions, instruction encoding, what the fuck? Instruction encoding, number of operands, instruction encoding, instruction set implementations. There you go. Oh my god. There you go. I know it's risk. Comparison of instruction set architecture. Okay, comparison of instructions. There you go. exactly. Data representation, bits, digits, endianness. But do we have now? Okay, CISC and RISC. And now there is a new architecture here. Okay, that's CPU microarchitectures. Okay, I just want to let me see if byte and go. Let me actually ask that in Twitter or X, you know. Does the byte go say byte go byte go YouTube architecture. Chill. Architecture in byte go, but it's more like micro CPU top architecture pattern. I laugh because this is something that what I'm doing here is just connecting the dots, and that's something that you should do that by your own, you know. What I'm doing here is just recording this set of videos as a way to now closing the gap between this knowledge and then now condense that in a way that it make meaningful, so it makes sense for others. So architecture by go. So you got is this top architectural pattern, computer. This is type of memory system, a system design conceptual. You must know what is scalability. Microservice and architecture, process and thread. It's interesting. applying architecture patterns. Oh my god, why so French those guys to get that? Does the computer architecture computer architecture? That's a good question, because most of the time is so as a way to go in here to sys or risk. Okay, that's right. Sys or risk. Okay. Computer. Can you make this here in English? Be my guess. In English, be my guess. In electronic and computer science, in computer architecture, like this, role definition, instruction set architecture. So this design issues. The risk idea and superscalar. So regardless, go back to here. So now that we have this set of rules in which how this communication end to end will happen in a reliable way, connection based, TCP. So despite of how these two ends, computers, architecture, the way how they organize, whether if that follow a risk, reduce instruction set, reduce instruction set. How the fuck is this? Reduce instruction set computer or complex instruction set computer. All right. This is now at the CPU. I think it is. Exactly. Okay, so just to verify that. The CPU architecture. CPU architecture. Exactly. So despite now how this central processing unit is organized, whether it is a reduced set of instructions or RISC, right? Reduced instruction set computer or a complex instruction set computer, regardless how these things is working, all right. Now, and this is also at the CPU level, at this small component, and regardless how also the architecture. This is now motherboard. motherboard architecture. Okay. So regardless how the CPU is organized, the architecture, and where that CPU is going to live, which is this motherboard architecture, and also no matter which OS this stuff is using, or any other application that is using on top of the motherboard architecture, we want is to guarantee that communication. And that's why now the OC model came around, this open system interconnection, where it need to pass through a different steps or algorithm, as you can say, right? And that is the OC model. Okay, the OC model. Yeah, let's go with Cloudflare here. So we need to pass through these several steps or different layers, where the data is going to be treated in a way that is now makes sense and aligned to the TCP, and send over in a useful way. So now we can actually make sense to establish this communication. So it passed through the application, but it's now communicating to the network services. And then on the presentation, it ensures that it is in a usable format, and this is when encryption happens. Then you have the season layer, where now the computer is preparing the port and season, right? It maintains connections, and controlling is the port and the season where this data is going to be sent over. However, we don't have the information of what are the set of rules that guarantee these communications end to end. And this is TCP or UDP, whether it is connection based. All right, let's going to guarantee this communication in a connection based way, or I don't care if there is someone else on the communication end, on the other end, but what I care is that I want to send data to that, or UDP. Right, and here is when you have now the nature of, for example, HTTP 1.1, WebSockets, HTTP 2, which is just an enhancement of the HTTP 1 that allow you to, for example, is use the server send data or server send events, and be capable to handle now more incoming requests, or handle more throughput. When it comes to now send data from server to client, all right, and then on the UDP we have now is the HTTP 3, which is something that we don't have. That so HTTP 3 for that. Okay, so HTTP 3, which is that is now executed on Quick, which is a protocol. It's a transfer protocol, and this is the important part of this hard part of Node.js, is to understand is now the networking aspect of that. So since HTTP 3 is running on Quick, a new protocol, a new transfer protocol, okay, it's a new way of how we're going to now communicate in a reliable way. The Quick, all right, Quick is designed to be faster and admit chains between networks. It is based on the UDP protocol, user datagram protocol, instead of the TCP, which mitigate a problem called okay, can you deliver this in English? Be my guest, please. Which would be an issue called head of line blocking in TCP, where network packet loss or reordering can slow down high transactions connections. There is a problem with the TCP. despite that you are now sending is all of this data, this message over the internet or the network, which indicate what is the physical path that this packet needs to go through. Okay, and then on the data link is established now the format, the set of rule of how this data is going to be transmitted on the network, all right, and across end-to-end device. And then the physical network is what is going to transmit that. So it transforms all of those data from previous layer into raw binary data. So why am I mentioning this? Because this is also part of the hard part of Node.js, or the server in itself, as a way to now is be able to have access to a computer that is miles away from here. Okay, right now I'm currently in Buenos Aires, Argentina. So I now can connect to this Cloudflare servers that may use some CDN, this cloud delivery network, which is geographically closer to the end user. This Cloudflare might be located on Brazil, I'm supposed to. Let me ask that for Claude. Right. It's like, how can I? Yeah, it's like, how can I? Okay, so how can I? So how can I know? Okay, so how can I know the closest, geographic location of a website from the client. IP lookup geolocation tools, IP2 location max find or IP info, round trace out in MAC or this trace route domain. They show the path network packets take to reach the server, often revealing geographic hints. Okay, let's go with trace route. For Mm-hmm. Okay, so if I say now on Mac or Linux, this one, let's get into warp here, and then we say, hey, it's gonna clear this. You're gonna open a new one, tab here. This is not getting updated. What about now? Okay. Okay, cool. So trace route, and I want to do this inspection here. For this website, right? Unknown host. There you go. Okay, it tells me that there is an unknown host. No problem. So this unknown host here, if I say, for example, something like this, trace route unknown host. Do you know any? Okay, let's go. Man, trace route. Okay, this handbook. Yeah, this handbook. All right. And then you got here. We're connected together by gateway. So trace routes utilize the IP protocol time to live. Yeah, but as server. So a couple example here. Trace route need.nest. Oh, it's because they don't need is the protocol. You just only need is the okay. Print the route package, take to the network host. Okay, so in other words, it say you don't need to pass the protocol. I need only is the host. That's right. It passed through this. Okay. So trace route is a warning. Cloudflare has multiple address using this. So the maximum hops that it goes through is 64. That's interesting. Oh, it doesn't tell you anything. So you can trace that. While you're seeing timeout, Cloudflare security measurement configures the network to not respond to a CMP package, which trace routes use as a security message to prevent certain type of attacks. ISP filtering your internet service protocol might be blocking ICMP package beyond their own network for security reasons and router configuration. Alternative approach is using my traceroute. This tool combines ping and traceroute functionality and might provide more information. This uses TCP packets instead of ICMP, which might bypass some filtering and use this one. TCP trace rate. Oh, okay, it's because now it's using behind the scenes the ICMP until it reaches the hotel account. Exactly, this is not a command, and the other is this mtr. This is not a command. But again, the idea here is that with this, with that particular understanding of this, Quick can better support mobile heavy internet usage in which people carry smartphone and constantly switching from one network to another as they move about their day. This type of internet usage was not common when the first internet protocol were developed. Devices were less portable and did not switch network very often. You know, you have now, look at this. This is interesting to acknowledge all of these particular problems they have. First, we have is how we can control the network through MCP, because that works reasonably well for a small network. When you need to combine or add more different networks and guarantee the communications from one device in one network to another, it becomes a nightmare. So they focus now is on how they can realize the communication here from one point to another, and that is the TCP. However, because now back then devices were not that portable as today, so they didn't consider that device at the end communication can be in a different network or in a different network, and can make multiple jumps, multiple hops over networks, right? At least the server is the same, but the client is jumping across network. And that's why now they define Quick to support mobile heavy internet usage. We are constantly jumping from one network to another. Makes a lot of sense. Okay, Google started work on an early version of Quick in 2012, and in 2016 it was adopted by the Internet Engineering Task Force, a vendor-neutral standard organization, as they started creating the new HTTP 3 standard. After consulting with experts around the world, the IETF was made a host of change to develop the no standard version of Quick, published as the release for Common 9000 in 2021. Holy F, bro. This is yesterday, or this is a second ago in internet times. Holy moly, bro. This is the internet standard track document. The abstract. This document defines the core of the Quick Transport Protocol. Quick provides application with flow control streams for structured communication, low latency connection establishment, and network path migration. So network path migration, okay, and low latency established connection. Quick includes security measures that ensure confidentiality, integrity, availability in a range of deployment circumstances. A companion document describes the Internet of Integration. So I just want to actually make a quick draw here. It's going to make a quick draw. So Excalibur, Excalibur. That's right. So because it all starts with the network, we can think of this. I'm gonna put now different mobile computers here. Let's see. Yeah, this maybe. Okay. So because now it all starts with this, right? And let's going to put now a keyword here. And then a mouse. So here you have now, for example, is this one. Alright. And here you have a lot of these small buttons here. Why not, bro? Or you're so annoying. Right? I'm gonna say, hey, let's go to now copy all of this. Look at this, and follow with this. And there's another one, and there's another one. And there's another one. And you freaking get the idea, right? There's another one. And you say, hey, let's go to put now this. And there's another one. Right? Something like this, and do this, and do this, and do this, right? And it's going to add now a mouse here, or something like a mouse, something resembling like a mouse. Okay, right? Okay, so now let's actually make this. Okay. Oh, that was beautiful. I really love it, because now this computer, let's go to actually wrap here. Because now this computer wants to communicate with another computer somewhere else in the world. Okay. And let's say, I'm just gonna put this just like that. You know. And let's make this. Let's make this. So because this computer needs to communicate with another computers, okay, and that communication needs to happen, okay. You have this one, and you have another computer, and another computer here, and then another computer here, right? So for small networks, you know, for small networks, oh, okay, that's interesting. That's lovely. Okay, so for small networks, NCA actually works quite decent, right? So NCA, right? Or the network control protocol, right? So the network control protocol, like this, the network control protocol. The problem with this is that issues or you can say the trade-off. So the trade-off is, hey, well, good for small networks, okay, but when it comes to add new network, for adding new or for interconnecting, because it's that for interconnecting new or interconnecting other networks, it becomes problematic. Okay, which is this one. That's right. That's what it is. That's initially here. Okay, that's initially here. Good for small networks. For interconnecting other network, it becomes problematic to trying to control it. Okay, that's the problem with this. That's the issue with this. Okay, all right, good. So let's say TCP. Right, let's say TCP. Right, so TCP. Let's say TCP. This transmission control protocol. So they say, hey, instead of focusing, okay, that's right. So instead of trying to control the network, okay, let's define a set of rules to control. Okay, let's define a set of rules to control the network communication. Okay, to control the network. So instead of trying to control the network, okay, the network, let's define a set of rules. Let's define a set of rules to control the network communication. Okay. The essence of that. Okay, so instead of trying to control the network, let's define a set of rules to control the network communications. Okay, so it is easy to add. It is easy, making easy to interconnect different networks. Okay, make it easy to connect different networks. So if we go back to our example here, which is this one, and then you say, hey, this is now a small one, and then you have now a different one, right? It's going to now reorganize this and say, hey, this is here, and then you have another one that is here. All right. and then you have another network here, which is this. Okay, and then you say, hey, something like this. All right. Okay. Lovely. Lovely. Right. We have this another network. And something that is quite similar, but in this case is something like this. You know, this computer and this computer and this computer and this computer, you know, and this another computer. Or this computer, you know, it's like, so now we have different topologies here. Holy moly. And now it is easy for us to connect them. Why is that? Because we are now focusing on the problems that we're trying to solve, and that is that one. You say, hey, this is bidirectional, and we have another here. We say, hey, this will connect to this one, and this will connect to this one, you know, something like that. You can say, hey, no, let's go to path this through this or through this. I would like to, yeah, prefer to use this node for that, you know. So, but that's the general problem that we're trying to solve. Okay, and I think this might be a very good introduction of why TCP emerged and why MCP we got this. Okay, so we can say is, hey, this will be this one. You can answer is that why. This is why TCP emerged, right? Say why TCP emerged. This is a good question, right? So this is a good question. So this stuff here, why TCP emerged, right? Let me actually put it now. No, bigger one. Really? Okay. Okay. No problemo, amigo. No problemo. Okay. So why TCP emerged? Can we? Yeah, they have this finite set of stuff. But in any case, so this is why TCP emerged. Okay, but this is now on the network layer. This is part of the, as you can see, the network layer. So you can, this is now the, I mean, this is the transport protocol. Transport protocol. Okay. Which is what we want to make this stuff here, you know. Where in the F is the OC model? OC model here in 3. So Cloudflare. There you go, right? The transport layer. So this is part of the transport layer. This transport layer Okay, this transport layer, and if we can make this a little bit smaller here, so we can now zoom in to understand that a little bit more. Okay, and you say, hey, wow, that's powerful. And I say that's powerful because it does that in real time, and it doesn't collapse here, and it works pretty fast, bro. It repaints that pretty fast. So this is the transport layer, right? Wow, that's awesome. I must admit. Okay, this is now the transport layer. Okay, and here, because we're using is now the TCP connection layer, which is TCP, TCP IP, or UDP. All right, at least this is the most common one. All right. This now belongs is to the OC model. I want to make this a little bit more here. This is the transport layer. This is part of a more bigger layout that is the OC model. Okay, and because what is relevant for our case is just to know about this one, okay, which is, hey, you know what, this is the application. Where is this? Is the application, you know, oh, we can do this, sorry. You can say, hey, this is the application, you know, the application. So this is, you know, so this is when the app communicates to networking services, right? OS networking services, right? And then you have now the another layer, which is the presentation, right? Presentation. So this layer is responsible for saying stuff like this. You say, hey, adding presentation. So is to define the format in which this will be sent, ensure the data is in a usable format. So ensure the data is in a usable format, and this is when encryption happens. Okay, good as well. I'm gonna make this stuff a little bit smaller or thinner. I would like to make things thinner, you know, thinner. Yep. A little bit thinner, that's right. And then we have is the season layer. Say the season layer. So here is when we say, hey, you know what, this is when we controlling ports. Okay, so maintain connection, and you got it. So this is when you maintain maintains connections in controlling seasons, controlling port and season, maintain connections and controlling ports where this data is going to be sent over, port and seasons. Okay, and this is now the transport layer. Okay, what is the protocol that we're going to use to transmit this data? Like this. All right, and this is so what is the protocol that we're going to use to transmit data? To transmit data, HTTP, is TCP or UDP are by far the most common. Okay, so far so good. So yeah, there is no need to actually do this. Okay, so why TCP merge? And I love this quick tangent here. TCP is connection based. All right, TCP is connection based. UDP is connectionless base protocol. All right, so why this is important? Because we're gonna now then later on bind that together. Okay, and in fact, let me actually make this stuff here a little bit smaller. Yep, much better. I want to make them even more thinner, more thinner. Okay, like this, season. And if you want to expand that, it is up to you, to whoever is going to use this. But again, we did this, right? Application, presentation, season, transport layer, and why TCP emerge. So for small network, good for small network, but for interconnecting, not efficient if devices jump from one network to another. Not efficient for devices jumping from one network to another. And that's what we have now, the UDP, or this particular layer, the HTTP3. But in any case, that goes beyond the scope of this. And then we have now the another layer, which is the network. Let me copy paste this one. In fact, all of this. All right, and then you have now the transfer, the network. Okay, network. This is now indicates what is the physical path that this will take. Okay, decide which physical path the data will take. Decide which physical path the data will take. All right, good. And then you have now the data link, or the data link layer defines the formatting of the data on the network. Data link, so defines the format of the data on the network. Exactly. So how this data is going to be sent over the network. And then you have now the physical one. Say physical. Say physical. Let's get physical. Exactly. The physical. So sending raw data. Transmit raw bit streams. So transmit raw bit streams of data, right? Transmit raw bit of streams of data over the physical medium. So all of this, okay, is something. So the OC model, so the, say that this one. Okay. Okay, so with that, all right. Okay. Okay, but at least it's just to have now an understanding of what the thing is going on behind the scenes.
Hello, and as you can see, this is a different outfit and a different day as well. I just paused the video and this recording. So in today's video, we're gonna keep up with the hard parts of Node.js, but as a way to finally now develop and design this diagram that allow us to project is that allows to describe is now the computer, how the computer actually send data over the physical medium, which is part of the networking. So we are now combining is the software developers with the networking aspect, and also is the communication that needs to happen between end to end, right? So the client and the server. And what happened when you, from the client, send a message? So for example, you navigate to Twitter, you want to read your tweets. What happened during that communication, and therefore it reached to that another computer, aka the Twitter server. And we're going to now explore what's going on there using now is Node.js. So let's get into this, right? Yesterday we're trying is to inspect is the physical path that this might take. I think as we use trace route, we can see is the physical geographic location of that, like this. It might take some quite time to figuring out, but as you can see is because it has multiple address, okay, at least Cloudflare is using multiple address. First is to protect themselves from any attacks, and even and also from the DNS. So it doesn't tell you explicitly is what it is, but what we can look at this is that it's now going to this particular domain or this host, which with the extension of R of Argentina. Well, we are actually now in Argentina, so that's one of the reasons why we're doing this. But again, if we go back to what we really care in today's video, oh, don't tell me that shit. I think you got it. Oh, of course. Oh, I need to save this, bro. Let me see if this if I save this. Okay, so it stored that in my local computer, which is great. Okay, that's a relief. Okay, that's awesome. Okay, so go back here to this screen. Alright, we need to find a way to actually save this. Okay, so but the point of this is to understand that this is now the OC model, or the open system interconnection, where it's gonna pass through all of these particular layers that live inside of our computer. Okay, I'm gonna put it here, the OC model here. Say this is the OC model. The OC model. Okay. In this OC model will live, okay, in our computer. It will live in our computer. Can we not? Okay. it will live in our computer, right? This will live in our computer. So we can think that this is our computer. Let's gonna make this as it is. Okay. This will gonna live in our computer. Okay. So this is our computer, or the client computer. Okay. So this is the client computer, and since we have now is yeah, this is the client computer. I'm gonna make it this a little bit bigger. Why is that? Because we want to also draw is the it's another things that will be is the OS, which is the operating system that this is being run, you know, the OS, the operating system, as well as that inside of this operating system we have now the browser. Okay, let's say, hey, this is now the browser. It's gonna make these things here. All right, this is now our browser. So the browser here, yeah, this is the OS. Okay. So the browser here, okay. So anytime you now send a message, you're gonna communicate to the OC model like this, you know. It's gonna communicate to the OC model. All right, so the browser here, so the browser, anytime you type a URL, is going to communicate to the OC model that now will send this data here over the physical medium to the headquarters or to the client's computer. Can we now say something like flip horizontally? There you get it. And this is now called is the server computer. Okay. So, but the point of this, okay, is to at least you got is this. Okay, you got is this, and you got is this. All right, this will be now called is the cloud frame tool. Oh, this is a frame. Oh, interesting. This will be now known as the cloud. All right. Okay, let me put it this way. let me put it this way. This looks like a bread, but it's not a bread. This is like a cloud. Okay. Yeah, this looks like a bread, but it's not the bread, it's the cloud. But you get the idea. You can group the selection here. Known as the cloud. Okay, this is the cloud. This is the cloud, right? The cloud. What you're gonna first communicate is to the ISP, okay? To get now, where it first is going to talk to the DNS, which is usually hosted by the ISP, the Internet Service Provider, to get the physical path, or okay, the IP address of that URL. So once you get that, now it's going to actually send the data over the HTTP in Azure, blah 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 blah, and then I'm going to, with the physical location, aka the IP address, now I'm going to forward that message to that another computer, so then it can retrieve that data. So instead of this computer here, and this is looking for the networking, okay? This is kind of looking at what happened in the networking. We can also expand this a little bit to say, hey, exactly. So what happened here on the cloud? You know, what happened here on the cloud? So for our demo, for demo purpose, we're gonna leave that as it is. Okay. At least this is a networking diagram. Just gonna put it here. This is the networking. The networking diagram. Okay. So networking diagram, client server architecture. So why this is important? Because this will lay out the foundations of what is the next step. And let me actually save this. Save this. Shareable link, save the scenes to your workspace. Oh, this is to export that. What if I say save this on disk? Yeah. Authorize Scali ROM. This is networking. Okay. Interesting. Okay. Powered by Stripe. Okay. Well, Oh, that's interesting. Okay. Okay. Yeah, that's fine. That's fine. That's fine. That's fine. Okay. That's fine. So, but in any case, the point of this is to highlight that. Okay. Now, by looking at this particular diagram, is to especially here on how now the JavaScript node and the computer actually works together, that help us to intersect incoming message as a server. Okay. So far we have explored that now JavaScript doesn't have any label associated that we can have access to. And there's a couple of stuff first to understand, because first we need to know how JavaScript works, second how Node works behind the scenes, and also the nature of the HTTP. These three components is just a close scope of what nodes can do and why Node is so renowned. So we can actually understand is the inner mechanism of each one of those components, and therefore have a full knowledge and understanding of how these things work. So first we went through understanding is what JavaScript does. Well, it allows to save, store, and data to be later on, to save data and its functionality to be later, so you can use it later on. Also, it allows you to use data by running functionality on it, okay, and apply some sort of transformations, and allow you to access to web APIs or APIs that are exposed to this JavaScript environment, whether it's on, those are provided by the host environment, whether it is the web platform or in this case Node. So first thing first, we just analyze what's going on here, especially in JavaScript. When you store is the variable, when you tell now JavaScript to assign reserved spacing memory here, and I would like to actually consult to Claude here a little bit, because I want to know his explanation in a consistent way, all right, about here, about this. Let's examine or let's describe what JavaScript is doing line by line from the following code. Well, I would like to know how say guns, let num equals to 3, the other is cons num2 equals to 10, all right, and then you say function multiply by 2, you say function multiply by 2. What you're going to receive is an argument here, which is the input. I will say num. This is the function declaration. Okay, so first we're saying, hey, let JavaScript please reserve spacing memory for this label and assign the value of 3, which is a primitive. Do this. So this means that it's going to reserve a spacing memory for this identifier that can be reassigned but not redeclaring them with the value, with the name of num and the value 3. It's going to do the same for cons. It's going to reassign, it's going to assign the value of 10 to this identifier that cannot be is reassigned or redeclared afterwards. And then you go through here. That's going to now save space in memory for this function with the identifier called multiply by 2, and this is the set of instruction that you're going to do. So say cons. So inside of this, you're going to open up a new cons execution context where you say, hey, the identifier called result, I want you to reserve space for the identifier called result, whose values it'll be input number times 2, or in this case the num parameter times 2, and then you're going to assign that to the result. So in other words, you're saying, hey, I want to now reserve space in memory for the result identifier that cannot be redeclared or reassigned, whose value will be is num times 2. And then I want you to return this result. Okay? So far so good. And then you just call is here and say, hey, I want you to now define an identifier called output that cannot be declared, cannot be redeclared or reassigned afterwards, whose value will be is whatever the multiply by 2 identifier or label has assigned, which is a function. So this is how you describe a function here. Okay. And the value will be num. The value of the parameter that we're passing is num. And I want to define also another output here, which is, hey, new output label. I want to reserve a space in memory for the new output identifier that cannot be redeclared or reassigned afterwards, whose values will be whatever is on them, whatever the label multiplied by 2 is, which is a function whose parameter or whose argument will be num2, right? And let's get into this. Let them declares a variable named num using the let keyword and assign it to the let3. This variable can be reassigned later. Exactly. Declares a const named 2 with the value 10, and this cannot be reassigned or redeclared. There is a missing point there. Function multiply by 2 is a define a function name that takes one parameter called num, and you're going to store this set of instructions here. Inside of the function, declare the result at, exactly, and then call the function with the value of num, which is 3, and multiply by 2, and assign the results to a constant name output, and so on and so forth. So again, I prefer with my own description of what's going on behind the scenes, because it's much more clear of what's happening. But in any case, after we went through that, all right, and then we recognize is the components of JavaScript, which is the global execution, and then the function execution, the call stack to keep track of where you are in the code. These 3 components, and also the heap or the memory. So these 3 components are this tree component makes JavaScript synchronous. But if you need to deal with asynchronous nature, that's when we have now stuff provided by the platform, like the event loop. And now how the event loops has, for example, in the case of the browser, the micro task and the macro task. The micro task has more priority than the callback queue or the macro task. The micro task handles promises. Okay, anytime it detects a promise in the language, it's going to be put there. Or if you need to handle timer, it's going to put is on the callback queue. So this is great to understand how JavaScript and what JavaScript does, okay, and the anatomy of JavaScript. And also remember that JavaScript can have access to the feature exposed by the host environment, whether it's on the browser or the server. So now let's go to look at how actually Node execute code. All right, because one of the thing here, especially on the function that I mentioned before, is that we are now injecting manually is the parameters or the arguments here, the argument in that functions. But what we're gonna see later on is that now Node automatically injects the arguments to those functions for us, and that's now the mental model of Node. So before that, first we look at how now Node execute the code, at least from a broad perspective, and it say, hey, it expose now certain labels to the JavaScript world. So the host environment expose that, and anytime you want to access from JavaScript, whether it is the net or crypto or file systems or the OS or any other label that now Node exposed to us, it will now call internally the internal features, the internal computer features that will allow you to now is have access to that, whether it's to the networking services or the CPU, or to read the input and output. But particularly this will allow us is to have access to the input and output, and that is an inner mechanism known as the libuv, which is a cross-platform library for input and output. There are also newer versions of that, which is known as Tokyo, which is reading in Rust, but this is now reading in C and C++. So from Node, it can now have a mechanism to detect when an incoming message pass through is received from a socket, okay, or when an operation, another input and output operation, like waiting for a file to be read or write, is done. So this is quite interesting, because as we now look at and explore all of these particularly labels, specifically the net, which is what is relevant here. So net allows to create, okay, it's a model that provides an asynchronous networking API. Asynchronous networking API. So net allow you to have access to this asynchronous networking API. In other words, is that behind the scenes, the event loop is gonna detect when a network stuff happen, incoming message, for example, whether it is or by creating is a stream-based TCP server, this transfer control protocol, or an IPC server, internal process communications. And that's quite interesting. This is very, very, very interesting, because now these two concepts, the stream-based TCP or IPC, like this. So Moto supports IPC with name pipe and Windows, and Unix domain socket on other operating systems. Alright. Identifying path for IPC connections. But this is quite interesting, because now when you are able to use whether it's net to create a string-based TCP connections or an IPC server, but what we really care in today's video is to create now this string-based TCP servers. All right, that's why we have to explore the Excalibur. So Excalibur. That's why we have to explore this TCP stuff and all that kind of stuff. You know. That's what here. This is in fact is this one. That's what we have to explore. Explore is this, because now it makes a lot of sense of what is going on behind the scene in this architecture from the client and the server. Now it means that since we want to have access, so Node exposed now a more specialized model called the HTTP, like this. All right. So Node exposed a more specialized network capability called HTTP. All right. So this model contains both a client and a server, and can be imported via required Node.HTTP, Node.js, or as it is. So the HTTP interface in Node.js are designed to support many features of the protocol which has been traditionally difficult to use. In particular, large possible chunk encode message. Large particle chunk encode message. The interface is careful to never buffer entire requests or response, so the user is able to stream data. This is interesting here. What does it mean that you have to say that, my friend? You know, what's the problem? In the following code, in the following sentence. Really? Okay, let's get into this. The problem refers to memory use and performance. When HTTP server buffer entire request or response, they must allocate memory for the complete data. Increase memory consumption, introduce latency, must wait for entire request and response before processing, and limited scalability. Server resources get tied up holding complete data. By avoiding buffering, Node.js HTTP allows streaming data in chunks as it arrives or is generated. Okay, which enable handling large files efficiently and processing data incrementally without overwhelming memory. Please. Okay. 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 Now for real? Oh, but I think you are... Okay, but in any case, the problem refers to memory use and performance. When HTTP server buffer entire request and response, they must allocate for the complete data, which increasing memory consumption and introduce latency. So all of these incoming requests that it needs to buffer, it needs to allocate in this, it needs to allocate this data in memory for the complete data until that is complete. So with stream base, by avoiding buffering, Node.js API allows streaming data in chunks as it arrives or generated. So it's going to now stream data in chunks as it pays us the TCP HTTP stream of data, or is generated, which enables handling large files efficiently and processing data incrementally without overwhelming the memory, which is something that we're gonna describe later. But the thing here is that now this specialized model that exposed to us in JavaScript allows to create now HTTP servers, okay? And it's designed by providing some of the features of the protocol that has been traditionally difficult to use. In particular, large possible chunks encoded message for that. The interface is careful to never buffer entire requests or response so the user is able to stream data. So keys are lowercase, values are not modified. In order to support the full spectrum of possible HTTP applications, the Node.js HTTP API is very low level. It deals with it's very low level. It deals with streaming, handling, and message parsing only. It parses a message into a header and body, but this does not parse the actual headers of the body. See message headers for details on how duplicate handlers, headers and handlers. The raw headers are, as they were received, are retained in the raw header properties, which is an array of this. This is the raw headers. It's like, hey, content, and then you have now the classes here. An agent is responsible for managing connection, persistent, and reuse HTTP clients. So it manipulates a queue pending request, where it maintains a queue pending request. So it has now a queue of pending requests for a given host and port. Interesting. So you maintain, holy hell, it maintains now a queue of pending requests for a given host and port, reusing a single socket connection for each until the queue is empty, at which the time the socket is either destroyed or put into a pool where it keep to be used against for requests to the same host and port. Whenever it is destroyed or pulled depends on the keep alive option. Pool connection has TCP keep alive enabled for them, but servers may still close idle connection, in which case they will be removed from the pool and a new connection will be made when a new HTTP request is made for that host and port. Servers may also refuse to allow multiple requests over the same connection. Exactly. Servers may also refuse to allow multiple requests over the same connection, in which case the connection will have to be remade for every request and cannot be pulled. The agent will still make requests so that the server, but each one will occur over a new connection. Okay, but again, this is quite interesting because now that we at least explore what are this net interface is, and the HTTP, which is a specialized feature that allows to control from JavaScript very low level networking features by introspecting message from that. So here we are now evaluating is what's going on, but now in Node. So here we're saying, hey, JavaScript, I want you to now create this identifier called server that cannot be redeclared or redefined, and assign the value of whatever is this http.createServer function return. Okay, and let's get into this. What is the create server object returns? Okay, so it returns now an object like this. So it returns now an HTTP server. Exactly, it returns now an HTTP server that extends from the net server. And this net server, that can be whether it's a TCP stream base or a IPC socket or an IPC server. This class is used to create TCP or IPC server. But in our case, I would like to prefer to go with this one, with the HTTP server. So you have now check continue, check expectation, client error. Exactly. Event close, event connect. All right. And this, when it detects the connect, this is when you have now the request argument of HTTP, as it is a request event, socket, network socket between the server and the client and the head. The first package of the tunneling stream may be empty. Emitted each time a client requests a HTTP connect method. If this event is not listening, 4, then clients redirect a connect method will have their connection closed. This event is guaranteed to be passed as an instance of the netSocket class, a subclass of string duplex, unless your user specify a socket other than this. And then you have now connection, drop request, upgrade, server close, stop the server from accepting new connections. So all of these connections from this or from all of these computers that won't have access to you, and close all connections connected to this server which are not sending a request or waiting for a response. So here it also exposed this. So close this. The other server close all connections as well. Server.close idle connections. Server.listen. It's like, hey, now start from listen from incoming requests. The method is identical to the server.listen from net.server. Server listening, which is a property, indicate whether or not the server is listening for connection. Server does max header count. Limit maximum incoming header count. If it's set to 0, no limit will be applied. Request timeout. Ser timeout. Max request spec per socket. Server timeout. Keep alive timeout. Or keep alive timeout. And this is very interesting because this is all of the methods that you can have access from the HTTP server anytime you create now. So I want to now explore what's going on behind the scenes, and that's where we need to go through this, because so far it's like, yeah, it create this. So they create now an object that expose all of these methods as well as the net server, okay? So for example, like close, error, listening, drop, address, right? We can also check for the address, server.address, close, get connections, server listen. So yeah, all of these different other options again, but what I care is that, all right, now that this will return out these objects, and one of the properties that listen, hey, I want you to start accepting incoming requests. The question is that what's going on behind the scenes? And what's going on behind the scene is that, well, once we create a server via HTTP server in JavaScript that communicate to Node.js binding, HTTP to access internal features via libuv, or in other words, exactly, to accept via libuv this cross-platform input and output. Okay, this cross-platform input and output in libuv is a multi-platform library for I/O that interact with computer internal features like networking server, and then it create a socket by default on the port 80 for us. So since we can have from 0 to 65,535 ports in our computer, we want to only use a port 80. And here, because we are now telling that by default the port that HTTP incoming connection is this, okay, this is the door that it opens, the door number 80, and this is the diagram. However, now that we know what's the node is creating behind the scenes, I would like to dive into this particular code to explore more about that. So let's get into this. All right, let's get into this. So let's get into this.
And ideally, let's now, before we come to thumbs,
Okay.
come to thumbs in a second, I just want to finish up. I want us to have a Node is going to we are finally going to use our computer's internal features and either server, exactly, it immediately returns out into it an object full of functions, methods, they call them when they're on an object, methods, including ones like listen, all of which, when run, will allow us to edit the instance of the HTTP feature in Node that we've set up, give us editability over it. And that's exactly what we're going to have to use, because we need to tell Node to tell the socket to set up to listen at what point, Michael? What port, sorry? 80. At 80. And we can do that because we can go and grab that listen function, so we're going to do the next line, grab that listen function, pass it 80, and because this listen function is really a trigger to edit stuff in Node, is this going to do anything in JavaScript? Nothing that interesting. Instead, it's going to set up in Node. There's the famous purple N from Node. So in Node, the feature to have the port be port 80, which tells our socket to open the door at port 80. Folks, we are now ready to receive messages. If we go to twitter.com/Node, send a message to Twitter's computer now at this point, it'll land. It'll be passed through into Node. In 2 lines, this was done. Now, a lot of shit's going on behind the, a lot of stuff's going behind the scenes, but it's 2 lines in JavaScript to trigger a ton of, this is super sophisticated. Opening a channel to your internet at a specific entry point, super sophisticated. We do it in 2 lines. Okay, in comes the inbound message, incoming message from Sarah Rose. In comes, hey, it's unforgettable. All right, there, in comes the message. With the help of libuv,
In the diagram, we are
here's the problem, folks. This message,
describing.
we want to look at it, see what it's asking for, and send back the right tweets. Inbound web request, run code to look at it. You've got to run code to look at, just to introspect it, see what it says.
Exactly. In this diagram, we are describing
Like this, I guess,
is
like
what
this.
happened
If incoming
anytime.
message, then it's pseudocode.
Exactly.
Then
In this
send
diagram, we're describing
back
is what happening anytime.
data. But folks, I want to run this code in JavaScript. I don't know C++. When is this code going to need to run? In fact, I have no idea.
So in the diagram, we are describing is what happening anytime.
At any time, day or night.
We're describing is what happening.
Anytime. When is this code going to run? If I run this code when I turn my JavaScript on, JavaScript's single-threaded and synchronous.
So
It hits this line, and if it's
we
already a
are
message at like 5
telling
milliseconds in,
JavaScript.
hit this line, or not even that, 100 nanoseconds in, it's going to hit this line and go, oh, incoming message, no problem, send data back.
Let's
But the rest of
reserve
the time, we pass this line,
space
and we don't ever see it
in
again.
memory
So in comes a message, and
for
there's no
the
JavaScript code there.
label
I mean,
or
in
the
theory, we have this
identifier.
run just again and again and again, like billions of times. So that whenever a
So
message
for
comes in,
the
oh, it's running,
identifier
its next line it's going to run. That means we do
called
one thing in our app.
server.
To be able to only receive one message and have to run the same line, just in case the message comes in at any moment. So
let's reserve space in memory for the
That needs to be
identifier
done.
called server
Sam,
that cannot be redefined or redeclare.
Node knows. And so, perhaps
That cannot be
we're going to
reassigned.
Node to automatically run this
All
line of
right,
code
or
for us.
redeclare.
Beyond our control. But
They
how
cannot be
could we
reassigned
bundle up
or
the code
redeclare.
in order that it could be triggered
Okay.
to auto-run by Node? How can we bundle up, Mohammed? In a function. And that's what we're going to do, people, again and again. We're going to bundle up code in a
So we're
function.
telling
We'll have
JavaScript,
auto
let's
run
reserve
by
space
Node
in
to
memory
do stuff like looking at incoming message, send data back
for the
when
identifier.
Node hears with the help of lib.
Okay, so we're telling JavaScript, let's reserve space in memory for the identifier called server that cannot be reassigned or redeclare, whose value is exactly whose value is HTTP, whose value is uh, whose value is the returning value from http create server function. This is on line 1. This is on line 1. Okay, and then on line 2, since we can have access to the server object, we are telling, we're telling to JavaScript, hey, now I want to start to listen for incoming connections. Okay, I want to start listening for incoming connections, for incoming HTTP connection. All right, I want to start listening for incoming HTTP connection at port 80 at port 80. Question: how does the listening happens? Because at the end of the day is that. So we are actually exploring is that aspect. Exactly. So based on the image, I am describing here what's going on. To understand exactly, it calls Node.js create a network socket, bind it to port 80 on all network interface, and start listening for incoming TCP connections. Under the hood, the OS reserved port 80 for this process. Node set up an event loop to monitor this socket. When a client attempts to connect, the OS notify nodes and Node accept the connection, creating a new socket for that specific client. Oh, so okay, Node accept the connection, creating a new socket for that specific client. The HTTP server parses incoming data in HTTP requests, and for each request it triggers the callback function. This is a basic HTTP server that will accept connection but doesn't have yet logic to handle request or send response. But again, it's good enough. It's good enough at least. How's it going, everyone? Welcome, Javier Gonzalez in a different setup, as you can see. And here I am in a quite different setup, where this is a restaurant-like cafe bar. But in any case, the point of today's video is to actually explore now is how Node.js actually works behind the scenes, especially what happened when we call a function or one of these labels that are exposed to JavaScript, aka the net, any of these network API operations, okay, in the docs here. So what happens anytime when we call any of these labels behind the scenes? So far we know, at least in JavaScript, that what happens when we call from the host environment, aka the browser, set timeout. So we know what's going on there. It actually talked to the event loop. It has now a callback queue. And by the time that that file has been evaluated, then the event loop start to look at the callback queue and pass all of these functions to the call stack to be evaluated. Because now with the advance and the idea behind that, at the end of the day, we needed to deal with concurrency. So all of these tasks that overlaps at a time. At some point, we need to have some sort of mechanism that allow us to or that provide us a more easy way, a maintainable one, to develop all of these kinds of asynchronicity, or this application that need to communicate with others. So that's what we have, for example, is callbacks, thunks, promise, and also async and await. You also can replicate that behavior using the generators with iterators and promise like, as well as observables like rxgx and the like. And also there is something new called CSP that allows you to do that. But the thing here is that we know all of this, what happened behind the scenes, especially on the synchronous and asynchronous nature, which is great in JavaScript. Now we need to know is what is the inner mechanism when it comes to build servers. Okay, what's going on anytime we call these labels that are exposed to the environment, like cluster, command line. Specifically, we're going to take a look at the HTTP. We also have now the crypto, but the HTTP, the crypto, the net, the OS. But we're gonna dive deep into the net and a specialized model called the HTTP. So let's get into this. We want to know what's going on behind the scenes. So let's get into this. Let's get into this. All right, so yeah, that's going to be that. Yes. Yes. Okay. I hope that doesn't.
We then.
Yeah, but the point of this is, oh my god, I didn't bring that up for real. Anyway, let's get into this. Okay, so here we're going to evaluate is this. So what happened behind the scenes? Anytime, for example, you are now using any label that are exposed to JavaScript, so we can have access to the inner computers. So we can have access to the computer's internal features. That's great. And we can replicate this behavior anytime we need is to, for example, is use another models. So whether it's crypto, FS, you name it. But the thing here is that by exploring and understand what happened behind the scenes when we call, for example, one single model, we can extrapolate that to other models as well. Why HTTP? Because this is something that most of the time is what we build, is what we're going also to inherit from a lot of older code bases, and well, we need to somehow is help that business to fix their bugs, or so to fix, to improve, or to do a refactor without the fear of breaking something. So yeah, server, HTTP create server. So what it's doing behind the scenes, what we explored in previous videos, that it returned now an object for us, okay? And that object exposed certain methods that allow us to, behind the scenes, have access to all of these internal features. One of them is, for example, the listen. They're also, for example, if we take a look at this, of Node, right? I don't think it will open on, but if we explore here the Node as it is, right? I mean the HTTP model, all right? So this actually now create this. So you create now an agent that has all of these different properties. As you can see in the HTTP, you can create now an agent, a request, client request, a HTTP server, which is exactly the method that we are actually using from the HTTP, all right? That allows, for example, here is to create a server. So the point of this is to get yourself familiar with the documentation. Why? Well, it's quite obvious that you can get used to that, and when you need to find anything or any other features, let's say crypto, for example, oh, you know where to look. That's all. So this is HTTP server, HTTP server response, HTTP incoming message, outgoing message. That's interesting. And this particularly methods and status code. So status code, so like this, right? So hey, what is the status code of this incoming message that we're getting to? And also look at this. You can now from this model define get URL, request, validate header, and so on. Even use the WebSocket. But again, so far, what we're gonna look at this is these methods. It's only this line of code, which is this http.create. All right. And what is the object that is that exposed to us? Here is the return HTTP server, as it is. And this return this server object that it returns a new instance of the HTTP server. Let me see if I can look at this. It returns a new instance of the HTTP server. Let me see, HTTP server, like this one. So it's gonna return is this new instance, right? The HTTP server. We can have now all of these kind of events, which is interesting because these events now are provided by the node for us, the libuv. So this libuv, which is this is a cross-platform input and output, that is the responsible to detect what's going on when you create now a server, and this particularly events that is going to detect that, hey, if I receive now an incoming message, or particularly is if I set the connection, good. If I receive even the request as well. You know, there are several couple events that are emitted here. So check continue, check expectations, client error, all right, close, connect, connection, drop request, and upgrade. And well, some of the methods that we can use. So for example, close all connections. Hey server, stop this connection. Again, I want to briefly mention that since HTTP is a more specialized model from Net allow you to create a stream-based TCP server as well as IPC server. But this stream-based TCP server is something that we're quite familiar, which is what we're gonna do right now, as a way to communicate from client and server using this architecture. And the IPC server is for internal communication. The name suggests that, as the name suggests, the IPC, internal process communication. So in any case, this is just an important topic to at least understand the difference. And this is it. This is pretty much what the server objects is going to return once we create this, which is great. You may wonder, and this is a valid question, who is managing this? All right. This is managed by the event loop, all right, or in other words, by libuv. This inner mechanism that libuv has. So it's now the node with the libuv that actually is talking to the OS. If you can see here now at this diagram, okay, it's not the node bindings. Once you from JavaScript tell Node to create a server, it not only creates a new instance of these objects, but also is exposing some of these events that allow you to do this. All right. Okay. So let's get into this.
Run http.create server. Michael, that's how I represent my. We should probably draw this out again, but it's okay. Do on incoming. There it is. Do on incoming. In this case, it's going to be the whole.
Okay. Let's get into this. Again, this is a course taught by Jesus. Yeah, this is a course taught by Will Sentence, CEO of CodeSmith, the software engineer machine learning program, headquarters in New York, California, and London. And I'm just taking notes out of this, right? So let's get into this. Calling method in Node. So calling methods in Node. There you got it. Calling methods in Node. All right.
Code of the do on incoming. Do we save it, and where do we tell?
So let's going to explore. Let's going to analyze this code. To see what's going on when we call a node method. Okay. For example, http.create server, right? Yes. Finder here. No, please. Alright, Finder here. And the screenshot here. Okay, that's right. Let's go into examine this. So this do in common, that's one of the reasons why we explore about JavaScript and how JavaScript now actually call methods and how we pass methods to those, and incoming data and function set to going data. This is our part of the arguments that when we pass to them, we manually do that. Okay, so for example, in this silly example of how JavaScript now execute code, like this one, okay. So here we are now passing is manually these functions to that. So let's go and see what's going on here, right? With this particular function. So what is the function that are passing to Node that at some point it will execute that? Well, that is the do on common. Okay, that's what it is. So this is the function that's going to pass through that. And this is a good question. So what is the function? Okay. So what is the function that, and I would like to actually take a look at this.
Let's give her a hand. Thank you. Excellent. You're doing it. Very nice. Exactly. Spot on. All right. So people, it is at that moment online. There it is. http.create server. Create server inside the parentheses. Whatever we insert there, that code, which in this case is going to be the whole code of the join incoming function, the entire code of the join incoming, we give a label join incoming to all the code inside of it, is going to be, we're going to tell Node, please auto run this function when a message comes in. Because it's basically
So in the line, this is interesting. So in the line, const server http create server do on incoming. Okay, how do I make this italic? Okay, there you go. So in the line of const server http create server in line, here we are telling to Node, hey, please auto run this function you do on incoming automatically for us. And I think this is one of the core, this is the philosophy behind that. This is the mental model behind that. All right.
I use one line of code, right? So this is more easy. But if you understand how it actually works under the hood, everything else you know will see later on. It's so easy. All right, so there it is. We're going to have to tell, well, let's put, Virginia, tell me again what we do in the first line here.
First line, we're declaring a function.
Yeah, declaring a function. Declaring a function, exactly. Pull this up because it's the same code. We're declaring a function. Do one incoming, yeah. No, we're doing it just into memory. Do one incoming. There it is, do one incoming. Saved. That's how I represent my functions, people, when I save them. There it is, join incoming, and then, next line, we declare server. We did it earlier, so just the same, declare server. We then run http.create server. Michael, what does http.create server do in Node?
Okay. Manage the incoming request. Manage the incoming request. Exactly.
Excellent, Michael. Exactly. What does http.create server do in Node?
Opening the portal. So when we create a server, what we are telling to Node, and this is one of the reasons why we need to look at the HTTP to know what's going on, especially on the methods, right, that are exposed to us. One, for example, is the create server. Exactly. Good. No. Create server. This one. Okay? Because we want to know what's going on behind the scenes. Let me see if this tells something here. Returns a new instance of HTTP server. Emitted each time a request. And this is a method. HTTP server here. Net server. This class is used to create TCP or IPC server. Okay, just gonna check this. Net. Net.create and clients create connections. Okay. Okay. So it creates now a stream-based TCP. So this is pretty much what it's doing. So when we create a server with the HTTP model, what we're telling to Node is create a, which is something that is behind the scenes, is this one. Okay. Communicate with the, exactly, is so when we create the server with the HTTP model, what we're telling to know is talk to the libuv part that handles TCP, or that handles stream-based TCP connections. And here's when we started to connect this. Talk to the libuv part that handle the that handles stream-based TCP connections. All right. So talk to the libuv that part that handle the stream connection, that handles stream-based TCP connections. Pass auto run the do on incoming message, do on incoming function for us anytime an event is detected.
Excellent, exactly. And we then have it also return an object. It returns an object into server that has a bunch of functions.
Exactly. And then return an object
that allow us to edit the instance.
And then return an object that allow to edit our message from there. That allow to edit message. Yeah, that allowed to edit our message.
HTTP socket. It will also return an object. It returns an object into server that has a bunch of functions that allow us to edit the instance of HTTP socket.
Return an object that allows to edit the message on the instance of that HTTP socket. And this is quite important because this, what it do is, you started to see now the matrix here. It's like, all right, let's go to now explore. So let's go to create this function. Okay. So let's go to create the create server function from the HTTP. All right. This is a specialized model that allows us to create stream-based TCP servers that at the end of the day, what it's doing is, hey, at least in this line of code, is to tell, hey, Node, now that I'm here in JavaScript, I want to create the server, aka I want you to have access to that internal node, that internal feature that you expose to us, and this is the function that I want you to run, outer run, please. And behind the scene is now creating or communicate with the libuv part that handles this stream-based TCP connections, and then it's going to overrun our function do incoming, which is something that we're passing here whenever an event is detected, and therefore is returning now an object that allows us to edit the instance of that HTTP, or that allows to edit the message of that instance or the HTTP socket. This is quite interesting. Okay. Again.
But we do want it. Because when that message comes in, we need some JavaScript code to run up here. And we need Node, when it gets the inbound message, to trigger some code to go and run up here. Where, again, do I insert Z? Specifically, if you can be as precise as possible with your technical communication, where do I insert the function that's going to be saved in Node, that's going to auto run when Node gets an inbound message?
On the parameter the create server.
Parameter create server function.
I pass it as my argument, my input, the whole function definition to the create server.
So outer run the do incoming function for us.
Function call, do on incoming. That means all of its code is going to be grabbed and thrown down to here to be the function that auto run this function when there's activity. When activity meaning inbound, some sort of stuff happens, inbound message. Auto run what function, Zep?
Do incoming.
Do on.
Exactly. I would like to use that. Outer run the do incoming function for us anytime there is activity on that or an event.
Incoming. There it is. Auto run this function. Fantastic. Why? We don't know when the inbound request would come. We don't know when it's going to come. We have to rely on Node to trigger running some code in JavaScript that we can look at. And secondly, because we're going to see this again and again, JavaScript single-threaded and synchronous. All slow work, it's inherently slow, I guess, when a message comes in, we've no idea when it's going to come in. All work like that, including speaking to a database, including speaking to the file system. They're never going to sit around waiting in JavaScript because it can only do one thing at a time. So it can only speak to that database until it gets a result from the database. Instead, any task that will take a long time will be set up in Node and then have a function attached to it that will be automatically triggered to run when the background task either completes or has activity.
So essentially here you're saying so anytime we pass a function to no models, labels, what you want to call, that needs to wait or that needs to wait for some data is the libuv. So anytime we pass a functions to node models or to any node API that needs to wait for something is the libuv that handles that for us, so we can run our JavaScript code without blocking the main thread. Okay, I would like to double check this with Claw here as a way to say, hey, we got this. I want to double check if the following sentence is right. Anytime we pass a functions to any Node.js that needs to wait for something, it is the libuv that handles that for us, so we can run our JavaScript code without blocking the main threads. What is the F different? So we can run our JavaScript code without blocking the main thread. This accurately describes how Node.js delegate input and output operations to libuv, which use an event loop and a thread pool to handle asynchronous operations without blocking the main threads. Okay, it's using the event loop, exactly, the event loop, and the thread pool. So when you call functions like fc, read file, or make HTTP requests, libuv, you are not communicating to Node to say, hey, this task that will take some time to complete, all right, I don't know when, but it will do. I want you to be handled by the libuv. Hey, it's like stacking that on that. That's interesting. That's mind blowing. That's mind blowing, bro. That's mind blowing, fellas. Yep, absolutely. Oh shit. Okay. Oh crap. Okay. So you're starting to see the matrix. Okay. Okay. You gotta be okay. Okay. But it's this, bro. Anytime we pass a functions to a Node.js API that needs to wait for something, perhaps HTTP or any data that needs to wait for something, it is the libuv that handles that for us, so we can run our JavaScript code without blocking the main thing. Okay.
See this again and again and again. Let's now, before we...
This is now calling methods in Node. And let's now how that thing works truly behind the scenes. Calling a function under the hood. This is calling a function under the hood.
We come to thumbs. On thumbs in a second. I just want to finish up. I wanted to have a message come in. I wanted to have Sarah Rose's inbound message come in. Let's remind ourselves, 2 parts of calling a function. Executing its code, in this function going to come, And it's going to be presumably automatically. How do I execute code, Charlie? What symbols tell me to execute code?
Parentheses.
I don't see myself adding any parentheses on the end of do one incoming. So who do you think is going to add the parentheses?
Node is going to add the
Charlie?
parentheses.
Node is. But what did I say? There's another part to executing code. Taking its code and running it. What's the other thing that goes into executing code? Raise your hand if
The
you know.
argument.
Matt.
Saving data.
Oh, it's almost the right answer.
Oh,
Love it.
good,
But it's not far off. What is the other thing that goes into running a
The
function?
argument.
Executing a function, running its code, and honestly, yes, sort of, but be a bit more specific. Saving what data?
The argument, the parameter.
Virginia? The other thing that happens when I want to run a function is I have to do what's that?
But insert the argument.
Insert argument,
Insert the
insert
parameter.
data. Two things running a function. Parens on the end to make it run its code. The other thing, insert data. Do you have a, you know what, I have a feeling that wouldn't it be amazing if Node not only took this code, do one incoming's code, and auto ran it with what, Charlie? How did it auto run it? By adding parentheses. But also, if incoming's code and auto ran it with what, Charlie? How did it auto run it? By adding parentheses. But also, if it were there to help me out by auto inserting arguments, the other thing that is needed to run a function. And wouldn't it be damn fantastic if those arguments were the very data that came from Sarah Rose's Mac? Because then inside the auto running code, I'd have access to all the data I need to determine what to send back. That's exactly what happens. Let's have a look. Two parts calling a function, executing its code and inserting its input. Its
Two
argument.
parts to calling a function. Execute its code and inserting input.
In multiply by 2 to the input of 3, the argument's 3, and we, the developer, inserted it.
Calling this
We wrote it. I
function
see it. I wrote it. Look,
and
3.
then inserting this parameter.
Node
and
will
it's
not
going
only
to add
auto-run
that.
our function by inserting behind the scenes what, Charlie? It's parentheses here, just to say it for now. It's going to be correct the whole time. At the exact right moment. What's the exact right moment? When the message comes in. Should be tomorrow. Could be 7 weeks from now. Does it for us. So it puts the parens in the end. It'll also automatically insert whatever the pertinent data is, the relevant data is, as. Should we insert the word additional? Matt? I don't know what as.
Yeah,
No,
that
as
makes
the
more
input.
sense.
Ignore that word additional, as the argument, as the input to that function. I meant the word additional if you want down here. Sometimes it will additionally, even as a second argument, a second input, insert a set of functions in an object,
This is my
and that
blower.
those functions, when they're run, inside the auto run function, when the second input will be a bunch of functions that
Exactly.
we will have access to, that when they're run, will give us access back to Node, which might allow us to add data to the message to send back to the user. We're going to see it in action. That's exactly what Node does. Node insert.
So calling a function under the hood. Okay. So Node.
Let's now, before we come to thumbs, and thumbs in a second, I just want to finish up. I want us to have a message. Also, automatically insert whatever the pertinent data is.
Yeah, because
the
this
relevant
is
data is
two
as.
stuff that Node actually
Should we
does.
insert the word additional?
For
Matt?
us.
I don't know what as. No, as the input. Ignore that word additional. As the argument. As the input to that function.
So
I
Node
meant the word additional
runs
was
the
down here.
code function
Sometimes it
for
will
us when a
additionally,
request arrives
even
to
as
the
a
user.
second argument,
But it says no.
second input, insert a set of.
Is this one? Please be my guess. Exactly. Is this one? So two parts of calling a function. Executing its code and inserting its argument. This is the two parts of what Node does, at least in the HTTP dot create server. Okay. At least here, at least in the at least at the console here. Okay, this is the two part of what Node does when we call in a function, at least in the example com server http dot create server doing comment like this, that's right, is to call the function. One thing is auto run this function. Okay, so auto run this function whenever an activity happens. But before that, is to pass. So this is the two part of what Node does when we call a function. Is a pass the function or definition. So pass the function definition. That's right. So pass the function definition. Okay. Do on incoming. Okay. Do on incoming, and before, like so, the pass the function definition. The pass the function definition do on incoming. And then you have the passive function definition to on incoming, and insert the arguments, the argument, which is the values. Insert the arguments to this function, so we can have access to them. Insert the argument to this function so we can have access to them. So we can have access to them.
Functions in an object, and that those functions, when they're run inside the auto run function, when the second input will be a bunch of functions that we will have access to, that when they're run will give us access back to Node, which might allow us to add data to the message sent back to the user. We're going to see it in action. That's exactly what Node does. Node inserts two inputs, two arguments automatically. One is going to be, well, let's see it. Let's just see it. Here we go. Here it is. Let's have Sarah Rose's message come in. Here comes Sarah Rose's message. Here it comes in. She's asking for what tweets?
So he's calling the node tweets.
Great long distance reading there, Sarah Rose. In come the node. Here she comes. We'll learn more about how that's formatted, that message, so we can really investigate it. But for now, let's just know this. In comes the message. It's arrived.
Yeah.
In Node. But problem. Big problem. This message is formatted in a way that I definitely do not want to have to deal with in JavaScript. It's a string of characters. So it is an HTTP message. I can actually get access directly. If I instead set up my open channel using the net built-in label,
exactly.
then the data will come in. I'd actually get it back in here in just the pure stream of characters, the actual message itself.
Yeah.
But because I set up this background feature, well, before we see that, just a second, before we see that, in comes the message. What do we want to have happen at that moment? Zep, we've set up this background feature. Well, before we see that, just a second, before we see that, in comes the message. What do we want to have happen at that moment? Zep, before we talk about any inputs, what do we want to have run at that moment, Zep?
We want to overrun
do an incoming function.
Let's
take it up here,
function.
and it's going to, look at this, people. It's going to come into JavaScript. And folks, I'm going to do everything that Node's going to auto do with the purple pen. So, Charlie, what's the purple pen? The Node pen, the automatic, not done by us pen, going to have happen in JavaScript.
Is to overrun the do income function.
Charlie, losing your job, going to have happen in JavaScript at this point. It's going to execute code, so it's going to need more handling. dependencies. Not done by us, Pen. We're going to have
Exactly, it's
jobs.
because Node is going to auto-run that code from that by including its parentheses.
Charlie, you're losing your job. Any parentheses. Put parentheses on the end and execute that function. Folks,
So it's
we're
behind
going to
the
see this
scenes
again
that
and again and
Node
again.
is
This is
say,
what
hey,
Node
I'm going
does.
to run
So we're going to
this.
see this again, so we'll get very, very used to this model. But this function is auto-running. Purple means it's going to have, in comes a message, and it's going to auto-run this function. It's going to, what does it mean? What does that mean? Grab that code, throw it into JavaScript,
And throw
start
in
running it.
JavaScript, exactly.
And there it is. And what do we want this to do? Well, in theory, we want it to send a message back to Node to then send a response message, another HTTP message, back to Sarah Rose's Mac.
Holy
How-
moly, so by the time you receive this activity, it say, hey, this function somehow is going to notify that functions to run using the event loop by passing that function on this callback queue into the into JavaScript, and then by the time it returns that, it's going to now pass control
How are
to
we going
that.
to do that? We better have inside this function's code access to this inbound message and somehow access to this message going back. So we can add stuff to it, some data, some tweets, some HTML, some CSS, send back. Do I get these two strings of characters directly available to me in here? I actually don't, because Node wants to make my life easier. So instead, and this is the other big part of the process, we're going to see this again and again, folks, so don't worry. Instead, the next thing it does down here in Node, as soon as a message comes in, it's immediately going to set up an HTTP message ready to send back, by the way.
So
they're
to
in a
see,
format
as soon as it's received this
JavaScript.
string of
JavaScript is not great
characters.
at parsing text, we don't want to do that parsing text, but we'd rather not deal with it. At parsing PAR, parsing text. No, it's not, why don't we do that? So instead, Node is going to automatically package up
Package up two objects
JavaScript
for us.
objects
Mm.
for us. I'm
That
gonna
makes
do
a lot
them
of
in-
sense. Exactly. So he doesn't have to
I'm gonna
wait
do purple
for that
because
to
they're
be
being
run.
set up by Node. But they're JavaScript objects. It's going to auto-create them, number 1 and number 2. We're not going to give. They're not going to get names by Node, which is going to be weird. How are we going to access them? Shout out how you know how we're going to access them. You don't get names. What word with E? Well, we'll see that in a second. All right. So it's going to automatically create. When the inbound message from Sarah Rose arrives, it's going to immediately automatically create 2 objects. And these are the most important objects. Folks, you may be like, oh my god, when I just build my nice pretty app. But if we understand these 2 objects, we have everything we need to be successful Node developers. Now, I started off by telling you that Samir Buna guy, who's like the Node authority, through all the advanced, he's got a book called Node Beyond the Basics. And a list of 27 questions, interview questions that if you are asked in a Node senior interview, you need to know the answers to get a senior Node job. We're going to answer, and already, by the way, already we've hit like 3 or 4 of them, not more than 7 of them. I have no idea, but many of them already, because this is what's going on behind the scenes. 2 auto-created objects. The first one is going to package up for us in a nice JavaScript object format, because we love JavaScript objects. They're really easy to access and get stuff out of. It's going to package up the important information from the inbound message. What's the most important information we've got from the inbound message, Michael?
The request.
Yeah, there's no body here. We'll see that later on. What's the
Oh, the URL.
The URL?
The URL. And it's going to give us a little property on this object called URL, which is a string of, well, not the domain, just the
Holy
path, which is the
moly.
next bit here, the specific bit.
Alright.
It's /node, because that's what Sarah Rose wants. She wants Node tweets. And it's going to literally Node, and do the end to show you that Node's doing this, is going to look into that HTTP text message, it's a string of text, and grab out the URL. It's going to parse it, and grab out the URL and stick it in this object. And that object is going to be inserted automatically.
This is interesting because
into
now
this execution context. It was
it's
automatically
Node that is
created by
parsing
Node
that
automatically putting
object string that we're receiving
on
from
the
the
end of the
socket,
function that we passed to
and
it
now
during
it
incoming
creates
to say
these
when you
2
get an inbound message,
objects,
auto-run during
which is the
incoming.
parameters that
And there's 2
we're
parts
going
also running a
to
function.
use
One is
on the
running its code,
function when
and
we
the other, raise your hand
create
if you
the
know,
function
Junior,
that is going to be
Insert.
auto-run
Which is as good as
when
saving
there is
data. That's what it is.
activity
It's inserting data to
on
make it available in here,
this
saving it in here.
model.
Yeah. It's not a
Or
great
when
thing
there
to
is an
say,
activity, in
but-
this
so
case
that
on
wasn't
the
wrong, but it's
HTTP.
specifically, that wasn't wrong, but specifically it's inserting arguments. Okay, here they come. The first one is that
The-
first object with all the data we need. Let's stick it in. It's in the local memory. It comes in, Node people, without a label. So how the hell are we meant to access the property of an object that has no label? Michael?
You have to call it something.
Which we do. we give it a placeholder. We know when we say the do on incoming function, we know that when it gets run, it will have automatically by node inserted
Exactly.
2 objects. And so we give it 2 placeholder names that those objects will be
The
accessible
incoming
by.
data
And
and
we
the
call it
functions
whatever
to set
we
outgoing
want.
data.
As long as when we then try and refer to them inside the function, they have, we refer to them with the right label. And so what do we give, Michael, what do we give the object that's going to be auto-inserted the first
incoming
one, all the
data.
What do we give it? What do I give it?
Incoming data.
Incoming data. I don't call it request. We'll see, that's what we always use for the term in general, rec or request, but I don't want you thinking that's like a keyword. It's not, it's whatever we want to call it. Okay, there it is, incoming data.
But this is our
And what gets
just
inserted? This whole
parameters,
object
just arguments
with a whole bunch of properties, by the way.
that
I just
are
put in only
injected by Node
the
because
URL,
now it
but it's
did
a
a
whole
lot of
bunch
the
of
work
properties
for
added on.
us,
Headers,
like parsing
the
that
body,
opting of
yeah,
stream
body is captured in an interesting way,
into
which
that.
we might see later on. But all that data's on there. Okay, I've got all the data. But now, I didn't bring all that data in from Sarah Rose's request to not send some data back. My little message here to show that it's ready to go back. Oh, it's sitting there. It's sitting there ready to send back. Node made it for me behind the scenes. It's sitting there. Oh, I want to go back. How the hell do we get access to it? Well, wouldn't it be nice if the second object maybe had a property on it called maybe data, something like that, which we could then, hopefully that object would go in here, and then we could access and add value to it, add values to it, send back. That's not how it does it for some reason. Instead, here's what it gives us. It does give us an auto-created object, automatically created by Node, that yes, is inserted in here as the second input, but that object does not have a property on it that we can add data to that then gets sent back. Instead, that object
It has a bunch of
a
methods
ton, but we're just going to use
that
one
allows
now,
to
functions, methods,
communicate is to
including
Node.
one end, JavaScript functions, labels for when we run this function. So this object's going to get thrown back into JavaScript. We're then going to grab the end function, run it, and whatever we pass to it as its input will be used to add data to
That
its
makes a
response
lot of sense.
message.
Incoming data.
This object
and the
has all the data, or
functions
we can grab it
to
directly.
set going on
This
data.
object has functions that when run from JavaScript will be labels to update the data on the message that gets sent back. Fundamentally different behaving objects. One has actually got the data on it we can access. The other has functions that when we run them from JavaScript will be labels back into Node to add stuff to this message
Holy moly.
to send back to Sarah
Okay.
Rose's Mac. Let's see it in action. In comes the second auto-created object. In it comes.
That are
And this one gets what parameter
that are
name?
injected
Rich, what's
as
the parameter name
parameter.
for the second inserted object?
Function set to outgoing
Fantastic
data.
functions to set outgoing data. Is this a keyword, Rich? No, it's just whatever.
No,
it's just
it's
because they
just
came
whatever
in.
you
The
want.
auto-created objects are anonymous. They got no name. So we better have given them placeholder. We did. No problem. In comes the object. It has on it a whole bunch of functions, but one of them is end. And I think, I have a feeling, we're going to use that function. Oh, and look at that. What are we going to look for? Set which object via which parameter name are we going to look at?
Function to set outgoing
Which
data.
object?
that end.
Which one is the functions to set outgoing data object? And then we're going to look at what function
It's
on
an
it.
object that has a
The
method
end
to call
function,
to this.
and
Say,
that's
hey,
it.
welcome to do.
Exactly what we're going to run. Functions to set outgoing data dot end. Whatever we pass to it, which is here, welcome to Twitter. Say welcome. This function dot end, when run, has an intimate connection back to Node. It's a Node function. And it's going to send a message into Node, down to this HTTP message, where it's going to add welcome to the message, and then that message is going to be sent back to Sarah Rose's Mac.
Holy moly, bro. That's interesting.
Folk, we have in one.
That'll be all for this video. Take care. Bye bye.